This is Math 30-1. Again, we're going to continue with horizontal translations. We will continue to use y is equal to f of x, so the function notation where f of x is the absolute value of x. To demonstrate our horizontal translations, what we're going to do is insert the parameter inside of the function. So we get f of x plus 3. So the parameter plus 3 is inside of the function, and that looks as the absolute value of x. So the absolute value of x plus 3, like so. So to look at this, we're going to start with, again, a table of values. We'll set that up. We've already graphed the function absolute value of x, so we won't graph that one again. We're going to go on to doing the absolute value of x plus 3. So this time we're going to need to use slightly different x components or values because the translation is different. So we're going to start with -9, -6, -3, 0, 3, 6, and 9. And again, we've looked at f of x, or just the absolute value of x, and we know that in that instance, or for this function, we're going to have 9, 6, 3, 0, 3, 6, 9. When we graph that, that will produce for us our very distinctive V graph, or V-shaped function. And just to verify that, we're going to graph it again. So if we go to -9 as our x component, we have -1, 2, 3, 4, 5, 6, 7, 8, 9, and +9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so we end up with that -9 and 9 point here. We have -6, 1, 2, 3, 4, 5, 6, up, 1, 2, 3, 4, 5, 6, here, 3 and 3, 0, and as we go to the x with positive x's, when we graph this, oops, let's just go here, so we have up across 3 and up 3, across 6 and up 6, 1, 2, 3, 4, 5, 6, and then up 9 and out 9. And again, we can see that very distinctive V shape. Sorry, that's not a very straight line. That one's a little bit better. So we've seen this before, no surprises. Now let's look at f of x plus 3. So when we start with our x value, we've got -9. We add 3 to that -9, and that gives us -6. The absolute value of -6 is 6. So we have 6. Let's do, so that's with the -9. Let's look at the, oh, I want to change that. I'm going to make that red. See if I can, maybe I'll just erase that and write it in red. And, oops. Sorry about that. Try this again. So when we have the -9 as our x, our f of x plus 3 becomes +6. When we have -6, -6 plus 3 is -3. The absolute value of -3 is just 3. Next we have -3 plus 3, that gives us 0, and the absolute value of 0 is just 0. 0 plus 3 is 3, absolute value of 3 is 3, and we continue. 3 plus 3 is 6, absolute value of 6 is 6. 6 plus 3 is 9, absolute value of 9 is 9. And finally, 9 plus 3 is 12, with an absolute value of 12. So we can see that we're getting quite different numbers than we got when we did our vertical translation. And so let's see how that graphs out. So we have negative 9, so we move out horizontally. Negative 9. This time, rather than going up 9, though, we go up 6. So 1, 2, 3, 4, 5, 6. Then when we go out negative 6, we end up going up 3, 1, 2, 3. And finally, well, not finally, we go negative 3, and that gives us a y value of 0. So here we are. We have x is 0, our y is positive 3, so that point is right here. An x of 3 gives us a y value of 6, and there's my cursor. So we have x of 3 and a y of 6, and then an x of 6 and a y value of 9, and finally with a y value of 9 and an x value of 9, I apologize, and a y value of 12. And we can see that this produces our same distinctive absolute value shape, only now rather than being translated up, we've been translated to the left. So we have f of x plus 3, and this has produced a translation of 3 to the left. And let's just label our black one, and we have just f of x. And let's do and try another translation. Instead of plus 3, let's go f of x minus 3, which again gives us the absolute value of x minus 3. So instead of plus 3, we're looking at minus 3. And we'll go back, complete our absolute values table, our table of values, and see what happens. So if I have negative 9, and I'm going to subtract 3 from it, so negative 9 minus 3 is negative 12. We take the absolute value of negative 12, and that gives us 12. We take negative 6. Negative 6 minus 3 is negative 9. Absolute value of negative 9 is 9. We take our negative 3, subtract 3, that gives us negative 6. Negative 6, we take its absolute value, and that gives us 6. We have 0 minus 3 gives us negative 3. Absolute value is 3. 3 minus 3 is 0. Absolute value of 0 is 0. Okay, and let's continue. 6 minus 3 is 3. Absolute value of 3 is 3. And finally, 9 minus 3 is 6, with an absolute value of 6. So interestingly, we get our list in reverse, and that's because we've worked with multiples of 3. Let's graph this. So we have a negative 9, and that produces a negative 9 gives us a y value of 12. So 1, 2, 3. So we have a blue point of 12 there. Our negative 6 for our x gives us a y value of 9. So here. And negative 3 gives us a y of 6. And finally, 0 gives us a y value of 3. So we have a, notice that that point is the same as on the other graph, so we have an intersecting point there. Not that that's significant, just something to note. An x value of 3 gives us a y value of 0. Finally, or not finally, sorry, an x value of 6 gives us a y value of 3. And now finally an x of 9 gives us a y of 6. Sorry, 1, 2, 3, so here. Okay. When we connect our graph, again we see the distinctive shape, only now we have a horizontal translation to the right. So I'm going to, at this point, introduce some variables. If we take our function, we can have y minus k is equal to f of x minus h, where k and h are parameters, and they give us the units of our horizontal and our vertical translation. So the k is specifically associated with the horizontal translation. Sorry, let me correct myself, that's the vertical translation. And h with the horizontal translation. And notice that with our h, we can see that we have negative h, so when I subtract h, that moves me to the right. If I have a subtract negative h, which is ultimately x plus h, in this case, I'm going to move to the left. So my h value is 3 is to the right, and a negative h is to the left. But it appears, because of this subtraction here, that it's backwards. Just pay attention to that and be aware of it. Notice, if you remember from our last video, I talked about my my vertical translation as y is equal to f of x plus k. And all I've done is taken this k, and if I subtract it from both sides, I get y minus k is equal to f of x. So when it's on the left side of the equation, that gives us that counterintuitive of, oh, we've got a subtraction, but it's moving it in a positive way. If it's an addition, it moves us in the negative way, and so we just need to pay attention to that particular detail. I'm going to encourage you to go back to the lesson and continue. Thank you for listening. Bye for now.